Hi, my name is Sandra Gonzalez, and this is the MATLAB project for the class ABE 205 here at the University of Arizona. And first of all, I just want to give a little bit of background about why I made this program and why it's useful. So my program is called Calculating Center of Gravity, and this will just give you a little bit of an intro to it. Pretty much, most private pilots are required to do a pre-flight where they have to calculate the center of gravity for their aircraft. And this is just a little bit of a diagram of what airplane, the components of it are. So you have your propeller, your thrust vector, and then just your lift vectors. And when a CG is right in the middle, it is in proper conditions that the manufacturer requires. So if it's too forward, you have forward CG, aft is too backwards. So what this means and why it's useful is because when you have your center of gravity too forward, then you have a tendency of the airplane going forward or backwards if it's aft. And this is very dangerous when you're in, let's say, you were flying and then there's a storm or something happens that you lose lift, and let's say that you begin to stall. And if you stall and you're not within the center of gravity, it's very hard to get out of that stall. And what a stall does is the airplane starts to spin and it just becomes very, very uncontrollable. So that's why all aircraft are required to do this pre-flight training just to make sure that the center of gravity is within the limits. And this is just a diagram of that. For my program for using MATLAB, I made two functions. One for the Piper Warrior, the P28, and it will tell you the center of gravity and the total weight, and it will just ask for different components. And this just goes through the math. And these are all numbers that were taken out of my books, so they're very accurate with the aircraft that I fly. And this is for the Cessna P210, and this is just another function that calculates the center of gravity and the total weight for this aircraft. And all these numbers were brought from a manual that I have based on all the aircraft that I fly at Chandler Airport. And so I incorporated all of this with the script, and this just tells you what it's called, calculate CG, my name, and it's made for private pilots like myself to calculate the center of gravity of an aircraft. And it's very user friendly. It will greet you and ask you to input certain information, which I will go through. And this is just the programming using if-then statements as well as loops. And this will go through it and using arrays to plot certain things such as fuel consumption. And this is pretty much all of it for depending on what aircraft you choose. So all of this code will allow you to do all these calculations. And this is just a picture of the Piper Warrior that I fly at Chandler Airport, and this is actually a picture of the day I had my first solo, so that was a very exciting day. And so let's begin. We will go into the program. So I called it Calculate CG. And what will happen when you click is you will get a menu that, well, first of all, it just welcomes you to the center of gravity calculator and just tells you to make sure to select an aircraft and make sure that the values you get are within compliance of FAA regulations and the manufacturer's regulations. So I'll show you that the cancel button works, so that goes away. So let's run it one more time, and I will first of all show you an example of a good center of gravity. And actually, both of these aircrafts, even if you put outrageous numbers, usually it happens that the mass would be very large. The weight would be very large, but the center of gravity would still be within the limits because these are very stable and they're engineered so that they can be very stable. So I'll show you an example with the Cessna. And so it just asks you for your weight. So I'm 140. And this Cessna holds 5 passengers, 1 more including yourself, so that would be a total of 6. So much larger aircraft than the Piper Warrior, and it's very nice, very fuel efficient, as you'll see later. So let's say your front seat passenger weighs 150, and you have two other friends with you, and you guys are going to Sedona. So it's 300 pounds for both of them, and nobody else, just four people. You take approximately 200 pounds of necessities to Sedona with you, and it'll tell you the maximum here of how many gallons you're allowed to put into. And so let's say you put in 64. So a couple of things will pop up and let you know, so I'll go through them. First of all, I would like you to pay attention to the total weight. And why that is important is because even though an aircraft can be within the center of gravity compliance, it can actually be overweight. So the maximum for a Cessna is 4,000 for at least this Cessna. So this just tells you the total weight is in compliance. So you're fine with that. And then it tells you your center of gravity, which is the actual value that you can take a note of. And it will tell you if it's within the envelope and if it's not. So this one is. So that works. And then this graph will open up and do this. And this is just fuel rate consumption. So it takes into account your number that you put for fuel and the number that, and this is approximation again. Of course, this can vary based on, let's say you have a really strong headwind or just several factors. This is just a very close approximation of how much fuel is being consumed per hour. And at the end, let's just say it takes you around 3 hours to get to Sedona, you'll have a fuel amount left of 45.7 gallons. So that is very fuel efficient. And again, this is just very helpful. And I forgot to mention that this number is very important when you're doing your pre-flight information, because let's say that you were getting into an accident and you had not done your pre-flight, and it was because you got into a stall because your center of gravity was off. And if FAA finds that out and they find you guilty, you're actually not insured because you weren't following directions. So it's very important for all private pilots to do. So this is just how one of them works. So I'll clear all this. So we'll run it again. And now I'm going to show you an example of maybe just an exceeding weight. And I'll show you this with the Piper Warrior. So let's just say some ridiculous numbers. Let's say you weigh 500. There's a 200-pound passenger with you. And this one's only going to ask you for the front passenger and a sum of two back passengers because it only holds 4 people. So let's say there's 400 total with them, and you take a maximum of 200 pounds for this one, and let's just say you take 40. So this will tell you your total weight is this, which is exceeding the maximum amount for the Piper Warrior, which is 2,400. So that automatically flashes it that you need to either reduce the amount or something needs to change. And then it tells you your center of gravity is 91.85, so it'll just tell you that, and then it'll open up again rate of consumption, and it'll tell you that the amount of fuel left after 3 hours is 16.3, and you initially put 40. So this aircraft is a little bit more less fuel efficient, so this will just show you that. So that is how you do this part. Now let's try a bad CG. Okay, let's try Piper Warrior, and let's say put 1,000 and 2,000. And again, as you can notice, I'm having to put extreme numbers because, again, these aircrafts are engineered to be very stable. So that just gives you a little bit of a heads up that usually you'll probably be in compliance with FAA just because these aircrafts are very stable since they are made for private pilots. And you're not very experienced, so they always try and make them really extra secure. Let's just say you don't take anybody with you, and you don't take any of that, and let's just say you get a team. So it will tell you total weight is exceeding. Again, it's the maximum is 2,400, and it tells you that you are not within the center of gravity envelope, and which is if you're at 82.46, so you just got to change your configuration to comply with FAA standards. And this is again is just a picture of, a diagram of how important this is. And I will show you a little bit of the code to explain something else about the Piper Warrior that's a little relevant. So this set of if else statements show different categories of weight. So like I said, the maximum weight for Piper Warrior is 2,400. So in order to be in compliance, you need to be under that, and the aircraft alone with nothing else on it is 1,500. So that just tells you if you didn't add any more weights, then you would be at this unit at weights if you selected that. You didn't add anything to your program. And if you are within 2,000 and 2,400, it is called normal category, which is what the Piper Warrior is designed to fly in. It's just the range of weights that it's really, really good conditions. However, if you're from below 2,000, that means your aircraft is really light, and it's called utility category, which this program warns you that you just have to be careful when making banks, which are sort of like turns greater than 60 degrees, because in aircraft your turns are measured in degrees. And so this is just a little bit, there's extra information that this code will tell you that is very useful for pilots. And overall, it's using a lot of if-else statements, for loops, just plotting different information that is very helpful for a private pilot. And I just want to say thank you for your time, and I really hope that if you ever need this program, I know it definitely is going to help me out. If you ever need it, contact me, and thank you so much, and I hope you have a good rest of the day.